Today we shall talk about the basics of electronics, right? So when we talk about electronics, what are the basic stuff that you think you know and everyone knows?
Maybe current, like
Yes,
wires,
but the current needs to come from somewhere.
plugs,
Yeah, plugs, or if there is no plug, something is not plugged and it's working.
battery.
Yay, there you go. So let's maybe start from batteries or plugs, okay? So similar, this is how we show in the diagram for a battery. Okay, the battery. So you have a large line and a smaller line. Yeah? The large line signifies what we call as positive. The smaller line signifies what we call as negative. So this has two things in one, right? So there is a positive and a negative. So if you think of what we call as, there is current, right? You said current. Current is the flow of electricity that conventionally we say it flows from the positive to the negative. So, and these lines signify pieces of wire that's connected, right? So if we connect this, for example, right, current will flow through this wire. Would you agree?
Yeah.
Which direction would it flow?
Will it flow around from minus to positive and come to minus and positive?
Yeah, so it does. We do not show a current flow within the battery, but you're right that something is going on in the battery. But outside the battery, we say it flows from the positive, so it goes out in this direction. It'll go around, as you said. It'll come down this wire and go back to negative. Okay. Similar to plugs as well. So we'll show the plugs like this. And we have to mark which is positive and which is negative in the plug. It will go up, round, come back, and back to negative. Okay, but only for a DC supply, right?
That's a DC supply.
A DC supply is when one of the prongs of a plug or a socket is always positive and the other one is always negative. In our normal household supply, what we have is AC, right? AC means that many times a second, in our country, 50 times a second or 60 times a second, based on which country it is, AC flips over. So positive becomes negative, negative becomes positive, negative, negative is positive. It flips over constantly. We will come. You'll find, I see you are confused. Why is that? But you'll see that there are advantages, maybe a couple of weeks into it. Right? But basic, simple to understand, DC plugs, right? Used to be the case long ago, but you'd have the plugs in the walls which would be constantly positive, and you'd have some constantly negative, and the current will flow between them. Okay. So we talked about a source of electricity, right? And which is a very basic. The second thing is something called a resistance. So this is a source. Let's talk about resistance. Okay. Resistance is normally shown by sort of a sawtooth line like this. And the value of the resistance is sort of written below it, okay, whatever it is. When the current flows, right, there is a resistance to the flow. Right? So think of resistance as something which is trying to resist the flow of current.
Oh, so that stop it.
Yes, so it's trying to stop it. Okay, so in certain things resistance can be high, in certain things resistance can be low. It's a variable based on many things. The type of material, even if the type of material is the same, it depends on the length of the material, the cross section of the material. It depends on a lot many things. Okay. Now, quickly going back to the source, sorry, I forgot to cover one thing, is basically you can have, we covered positive and negative, but what we need to say is how positive is positive. You know, there are some batteries, like the little alkaline batteries that you use, they're 1.5 volts, you have seen them, right? Mm-hmm. So that signifies that they are 1.5 volts. The voltage that it can supply between the positive and the negative, if you put one of those batteries in, is 1.5 volts, right? Similarly, you know of the rechargeable batteries, right? So they are not 1.5 volts, they are 1.2 volts, correct? You have the lithium rechargeable batteries, which are around 4.2 volts. You got LiFePO, which are around 3.3 volts. So you have a lot of options. So just saying DC does not cut it. You need to show what value is coming, right? Because finally you will see that we'll come to mathematical analysis of all of this, right? And for those we need values. Okay. All right. So now we know that there is a source which provides a voltage potential, and we can define it by a number. The unit is volts, which is signified by the V. Okay. For resistance, the units is ohms, which is signified by this sign, which, do you know what the sign is? It stands for omega from the Greek alphabet.
Okay.
So that's the sign. So, you can have a resistance which is 100 ohms resistance. You can have a resistance which is 1k ohm. Do you know how much is that?
1,000?
Correct, 1 kilo ohms, right? You can have 1 mega ohm.
Is it a million?
Correct, yeah, it is a million ohms. You can also have 1 milliohm.
Is it 0.10?
No, it's 0.001 ohm.
What's
One, like a millimeter, right? So it's like the metric system, like, millimeters, centimeters, right? You don't really have a centiohm. You could, I guess, but people would say 10 milliohms instead, right? And do you see the difference in what I write here? It's a capital M for mega, small m for milli. Don't get them confused. Big difference, right? Okay, so that's the resistance. Okay, now we need to get back to where you started from, which was current. Why? Because we will mathematically show that current is nothing but an effect of source and resistance being in a circuit, right? So let's draw a basic circuit, right? So we'll have a source, okay, which goes out. This is positive, this is negative, and goes through a resistance. Okay. Now, one thing to bear in mind that these are all ideal concepts, which means they are not real life, because in a circuit, right, all of this signifies wires, and all wires, no matter how good they are or bad they are, they will have some resistance of their own. Okay, but in a circuit, when we draw a circuit like this, all these lines signify zero resistance until there is a squiggly. Okay, and that's the ideal concept. So if we think about even the wire having a resistance, we will put that in one place and say, oh, it's a squiggly line and the resistance of the wire is X. Okay. All right. So say, for example, the supply, the voltage supply, the source, is supplying 10 volts. Okay. And the resistance here, just to make things simple, is 1 ohm. Okay. And what is the direction of the current?
I'll go from plus all the way down to...
Correct. So the current is flowing in this direction, right?
Yeah.
Let's call it I. Okay. Now, the current in a circuit like this, in a closed circuit, is given by Ohm's law. Ohm's law says that current is equal to voltage by resistance. So in this case, where voltage is in volts and resistance is in ohms, and the current, the unit for the current is amperes.
How do you write amperes?
We just write with the A, capital A. And again, the things in front work for everyone, right? So you can write kV for kilovolts. You can write small m V for millivolts. Similarly, you can write kiloampere. Kiloampere is a huge current. You can write milliampere. Sometimes there will be microamperes, right? Which is 1/1,000,000th of an ampere. Okay. So in this circuit, let's figure out what is the current flowing, right? So let's see, what is the voltage here?
10 volts.
10 volts, correct, 10 volts. What is the resistance in this circuit?
1 ohm.
1 ohm. So if you divide 10 by 1, you get
10.
10. So the current that should flow in this circuit is 10 amps. Okay. This is the representation of Ohm's law, and you can obviously, you know algebra, you can multiply both sides by R, right, to give you IR equals V, right, because the R cancels off. So voltage is also equal to IR. You can also, in this form, you could divide both sides by I to give this, yes? So basically, just like any other formula, this has 3 variables in it. If you know the values of 2, it will give you the value of the third. That's the tool to getting the value of the third, the unknown. You must know 2 of these, though. Otherwise, you won't know that. All right, so questions?
So is it allowing all the voltage through?
The current through.
Yeah, all the current through.
Yeah. So look at this formula. Right? So here we had 10 volts. Let's keep the voltage the same. And the resistance. Now, it was 1 ohm. If this goes up, say it becomes 10 ohms, what happens to the current?
It'll go down.
It'll become
1 ohm.
1 amp. Yeah, 1 ampere, or we short it to 1 amp. What if this goes down? It becomes 0.1.
The amps will go higher.
Yeah, it'll become 100 amps. So think of it, lower resistance, more current. The way I used to think about this is think of it as flowing water.
Okay.
Right? All right, so think of it like you have a big bucket full of water here. The height of the water level in here, think of it that as the voltage potential. Okay. Now there's a pipe flowing out. Okay, just to the bottom, right? So if this is the voltage potential, all the water wants to escape out from here down to 0, right, to the pipe. That's what it will be, right? The pipe will spew out water. Think of the thickness of the pipe as being the resistance.
Okay.
If you have a thicker pipe, what will happen? A lot of water will come out, right? So the flow of the water is a current.
Okay.
So the thinner the pipe is, the less the current is. Right?
Okay.
And this actually works with something like a battery as well, which has a fixed amount of power that it can give out. Because think of this water as a fixed amount as well, right? So at one point in time it will run out, just like the battery runs out.
Okay.
Right? Unlike the supply current, which again, that's also limited, but for you and me sitting in my home, it's not limited, because think of it as a tap pouring in more water to keep the voltage up as you pour the things out.
Okay.
Right?
But if resistance, if you turn the resistance to 0.1,
Correct.
then how could you have more voltage than the battery is supplying?
You don't get more voltage. What you do get, so let's see, if R equals 0.1 ohm, then I equals to V by R, right? The voltage remains the same. The height is the same. But now, resistance, which means the flow is now, your pipe is now bigger, right? 0.1 ohm, which becomes 100 amperes. So the current is higher.
Okay, but how can you get higher current than the battery supply? Oh no, the battery doesn't supply current.
Yes, the battery does not supply a current. The battery supplies a fixed voltage.
But then why do we call it amperes instead of voltage, instead of showing how much voltage is going through it still?
Because the voltage is a property of the battery, it's a property of the source. Resistance is a property of the resistance. The current is a property of the circuit.
Okay.
Right? So in a loop like this, right, depending on where so if you take a multimeter or a meter to measure the voltage, if you put the meter across a battery, you'll measure 10 volts. If you put the meter on different places in the circuit, you'll measure different voltages. The voltage is not constant.
Okay.
Right? But because this circuit is a closed loop, the current is constant.
Okay. Yeah.
All right? So any other questions about Ohm's laws?
No.
Well, that's done for today. Thank you. Bye-bye.